All right, so we've talked about putting everything into the calculator and creating quadratic regression. Now, the next part, excuse me, we're going to talk about not just using quadratic regression. Now we're going to talk about using like linear regression, cubic regression, quadratic again. We're going to talk about linear, square root. We're going to talk about logarithmic, exponential regressions. We're going to even talk about power regressions. So all of these functions are coming into play. So all of your parent functions pretty much are on here that we're going to look back at. Now with this, we've talked about just quadratic, but now since we're looking at multiple different ones, we have to figure out which one is the best one for each equation. Now there are two ways of doing that, and here it is. So finding validity of a regression model deals with two things: the coefficient of determination and the visual fitting of the data. Now this video and our next example is going to deal with the coefficient of determination. And then the last example for this whole section of regression is the visual fitting part. So here, to do a coefficient determination, we're going to look at this. Coefficient of determination is r squared. So in your calculator, when we do this, you're going to see r squared in there, and you have to know that means coefficient of determination. Okay. Now, here's a definition for it, though. And again, this is a definition, so therefore it is a vocabulary word. Vocabulary word. Woo, woo, woo. We love our vocabulary. I'm going to add it to the word wall. If it's not already there, it's going to be there in a few minutes. All right, so coefficient of determination is r squared, like we said, but it tells how well your model fits the data. So does it fit it really well? Is it jacked up where it doesn't even fit that much at all? It doesn't really fit at all? Or what's going on? What's happening? How does it fit? So when we do this, we have a couple of things to understand. The values of r squared will be between 0 and 1. So r squared is going to always be between 0 and 1. But the closer it is to 1, the better that model is, or that equation is. So if it's like 0.9999999, that's a good thing. If it's 0.98222, that's good because it's kind of close. But the one that's the closest to that, to 1, is the one that's the best fit one. The one that fits the model better, or the data better. Now here's how we're going to set that up into the calculator. So write this down really quickly, and then we're going to actually do that in the calculator so we can make sure we have it ready to go. And after we clear out the calculator, you have to do this every single time to put it back in. All right, so let's go ahead and do this in the calculator now. So we're going to hit the second button. Second, the blue button. We're going to hit the number 0, not letter, but number 0. And it should bring you up to this. So everybody should be there. And then we're going to hit x to the negative 1. So this button, x to the negative 1 button. And it takes us straight down to the letters, the D letters, because the D words, because we need those so we can get down to diagnostic on. So let's go all the way down till we get to diagnostic on. And that's it right there. Diagnostic on, right there. And what's it say to do next? Hit enter and enter. And it should say done on your calculator when you do that. So that's what we got. That's what's going on. Okay. Now, when it comes to our coefficient determination, do not round that number. So r squared, don't round it. You need to keep that number at written out as long as it goes. Because sometimes you might get something that looks like this. You might get these two numbers. Don't worry about the arrow yet. I'll talk about that arrow in a few seconds, and that arrow right there. Let's say your r squared is 0.984729813 for your quadratic regression. But then for your cubic regression, it said your r squared is 0.984729813. So with that, we said, okay, the one that's the closest to 1 is the one that's going to be the best model. So if we round it, they're going to be the exact same answer. But if we don't round it, we can see that here that 6 right there is higher than 5. So that means that this one is closer to 1 than the first one. So here, since that's the closest to 1, that is your correct answer. So with this, again, do not round r squared. Okay, so now we're going to go ahead and go to example 4, and we're going to go ahead and show you how to do another problem like this, but including the r squared and all that good stuff. All right, so let's go. Let's get it. Let's go.